Welcome to solverfy.
All right, so let's find the limiting reactant for this particular chemical reaction if we have 1.85 moles of sodium hydroxide and we have 1 mole of carbon dioxide. So to find limiting reactant, we're going to have to take each of our reactants to a product and see which one makes less. Now, the one I'm going to go to is sodium carbonate. And the reason I'm going to do that is because later on, the problem asks how much of that can be produced. So if I were to go to water, I would get the right answer, but then I would have to do even more work to figure out the amount of sodium carbonate. Now, if we want to find the limiting reactant, we're going to have to go to moles of sodium carbonate. So we're going to need the mole ratio. So if we have 1.85 moles of sodium hydroxide, the mole ratio is based on the balanced chemical equation. We go to what we want over what we had. We want moles of Na2CO3, and we had moles of NaOH. Now we look at the balanced chemical equation. There's essentially a 1 here in front of the sodium carbonate. There's a 2 in front of the sodium hydroxide. And so all we have to do is take that 1.85 and divide by 2, and we're going to get 0.925 moles of sodium carbonate. Now we'll compare that to the amount that we would get from the CO2. So we have 1 mole of CO2. The mole ratio there, we have 1 mole of Na2CO3 for every mole of CO2 from the balanced chemical equation. So that would make 1 mole of Na2CO3. Well, which one's lower, right? Or 0.925 moles is lower. So which is the limiting reactant? Well, the Na2CO3 is not the limiting reactant because that's a product. But we go back to where we started, and that means that the sodium hydroxide is the limiting reactant. Now, if we want to know how much sodium carbonate, how many moles can be produced, we already calculated that. It's the lower value. So this is the answer to part B. Now, how many moles of the excess reactant remain after the reaction? So the question is, when we're done, how much of the CO2 is going to be left over? So what we can do is we can say, all right, if we look at the 0.925 moles of sodium carbonate, we can make how much of the CO2 would we use? Okay, so we have our 0.925 moles of sodium carbonate, and we can work backwards with mole ratio to look at our reactants. Now, the balanced chemical equation says that for every CO2 we use, we make an Na2CO3. Now, remember, the one that you want to get rid of goes on the bottom. Here we want to get rid of Na2CO3. We want to know about CO2. The mole ratio is 1 to 1. So this means that we would use 0.925 moles of CO2. That's not how much is left over, though. How much is left over is the difference between what we had. We had 1 mole of CO2 minus the amount that we used. And so if we subtract 0.075 moles is in excess. That means it's extra. Now, 0.075 would be the exact number. If you're using significant figures, when we subtract, we can only go to the hundredths place. So you might have to write, if you're using significant figures, 0.08 moles excess.